Hi everyone. Today I am going to discuss the last subtopic of linear algebra, eigenvalues and eigenvectors with the properties. So far we had discussed basics, rank of a matrix, determinants, properties, system of linear equations, linearly independent vectors, linearly dependent vectors, etc. Now, before to start off that eigenvalues, eigenvectors, I am going to write a note point which is related to rank of a matrix which you considered as properties of rank also. Okay. Number 1. Row A, that is rank of a matrix A, is equal to R, implies and implied by, or if and only if matrix A has R linearly independent vectors, that is rows or columns or both. Suppose A is a given matrix and rank A is equal to 2. So such a matrix A has 2 linearly independent rows as well as 2 linearly independent columns. Okay. If a matrix rank is equal to 3, such a matrix has 3 linearly independent rows as well as 3 linearly independent columns. 3 linearly independent columns. That is called both. Okay. Second note point. If rank A is equal to R, this is also if and only if. Number 1, matrix A has a non-zero minor of order R. Number 2, every minor of order R plus 1 or more of matrix A is 0. Suppose rank of a given matrix 3 cross 4 is equal to 2. That is in the rank problems, first problem we have done. This matrix A has a 2 cross 2 submatrix whose determinant is not equal to 0. So 2 cross 2 submatrix determinant is also called minor of order 2. So that matrix A has a minor of order R. Yesterday I told you definition. Minor of order R means a R cross R submatrix determinant. That means minor of order R means determinant of submatrix R cross R submatrix in the main matrix A. Next, every minor of order R plus 1. For example, here this is R value 2. What is R plus 1? 3. What is R more? So 4, 5, etc. So in the main matrix A, if rank A is equal to 2, then every 3 cross 3, 4 cross 4, 5 cross 5, if that submatrices exist, the determinant is 0. So yesterday I told you, submatrix and determinant of an R cross R submatrix of a matrix A is called a minor of A. So minor of order R plus 1 means, so in the main matrix, every R plus 1 cross R plus 1 submatrix determinant is 0. Minor means related to determinant. Okay. You can check yesterday 3 examples. Rank of a matrix I have done. You can check this. Note point. Next. Sorry. Definition. The roots, that is lambda values of the characteristic equation determinant a minus lambda I is equal to 0. Are called the Eigen values or characteristic roots or latent roots of the square matrix A n cross n. So this topic, subtopic, completely related to square matrix only. 2 cross 2, 3 cross 3, 1 cross 1, n cross n, etc. So A is a given square matrix. The first step is form this equation. This is called characteristic equation. A is the given matrix. Lambda we don't know, which is a number or scalar. We are going to find that lambda multiplied by I. I is the corresponding identity matrix. So what is lambda into I? Every element of I is multiplied by lambda, then subtracting correspondingly the elements of A. Without multiplying lambda and subtracting from the matrix A, we can write directly subtract lambda from the diagonal elements of the matrix A. Suppose A is a 2 by 2 matrix. It has 2 diagonal elements. So subtract lambda from each diagonal element will give directly A minus lambda I. Subtract lambda from the diagonal elements only will give directly A minus lambda I matrix. You know how to expand determinant of a matrix. And after expanding equate to 0, which gives an equation in lambda. Such an equation is called characteristic equation. Every equation has roots. Roots means here lambda values. Such lambda values having special name Eigen values, other name characteristic roots. Okay. Characteristic roots. Sorry. See, for example, A is equal to 1, 2, 3, 4. So, how do you write the first step? Characteristic equation that A minus lambda is equal to 0. That means determinant. Subtract lambda from the diagonal elements. 1 minus lambda, 2, 3, 4 minus lambda equal to 0. You know how to expand and solving an equation, second degree equation, cubic equation, etc. If it is a 3 by 3 equation, if it is a 2 by 2 matrix, the last step of the characteristic equation is a lambda square equation, that is quadratic equation in lambda. If it is a 3 by 3 matrix, after expanding this determinant, which gives a cubic equation in lambda, that is lambda cube equation, and you know how to solve further. So after getting these lambda values, the next definition is eigenvector for each lambda. A non-zero vector x such that A minus lambda I into x equal to 0 or Ax is equal to lambda x. Is called an eigenvector of a characteristic vector corresponding to this lambda of matrix A n cross n. So the next step is finding a non-zero vector x. Vector means either row vector or column vector. What is non-zero vector means? At least one element in that column or row matrix is not equal to 0. That is called non-zero vector x. So there are so many non-zero vectors. So you have to find such a vector x satisfying this equation. What is that equation? Matrix A minus lambda I into x. That gives 0 matrix. I already told you how to write A minus lambda I. Subtract lambda from the diagonal elements of the matrix A. That matrix into this non-zero vector. Multiplication you know. That multiplication becomes 0 vector. 0 matrix means or 0 vector. So then that non-zero vector multiplication x is called an eigenvector, or another name, a characteristic vector corresponding to the lambda. So for when lambda changes, that x value also changes. That's why I wrote corresponding to this lambda. So how do you get this ax equal to lambda x? If you simplify, that is a into x, just multiply x minus lambda into I into x. I into any matrix is, it gives any matrix only. Yesterday I told you some properties, day before yesterday also. A into I is equal to A. So identity matrix into anything will give the answer anything only. Anything in the sense any vector or any matrix. Okay. So this is the definition of eigenvector. This is the definition of eigenvalues. So if I remove is equal to 0, which is a polynomial in lambda, such a polynomial is called characteristic polynomial of the matrix. In our childhood class, you know the difference between polynomial in x, equation in x. When the polynomial in x equated to a 0, correspondingly it gives an equation in x. So if you know characteristic equation procedure, what is that for characteristic polynomial? Just remove is equal to 0. Okay? Determinant a minus lambda I is called the characteristic polynomial of matrix A n cross n. So please go ahead. Please practice the 3 words: characteristic polynomial, characteristic equation, eigenvector. So when lambda changes, your eigenvector non-zero x is also changes. And for one lambda value, you have infinite number of eigenvectors. I will show you an example also. Example number 1. Find the eigenvalues and eigenvectors of the matrix A is equal to 3 by 3 matrix 8 minus 6 2 minus 6 7 minus 4 2 minus 4 3. This is the question. That matrix is a symmetric matrix. First row equal to first column, second row equal to second column, third row equal to third column. So how you identify according to the options the symmetric matrix? Row elements equal to corresponding elements in the column. Solution. The first step is characteristic equation. So I am writing in short form CH equation. CH stands for characteristic, EQ stands for equation. That is determinant. First step I am writing as usual, that is formula based. The notation, that A minus lambda is 0. Next step onwards. So I will start directly determinant, subtracting lambda from the diagonal elements. So this is subtract lambda from the diagonal elements. 8 minus lambda minus 6, 2 minus 6, 7 minus lambda minus 4, 2 minus 4, 3 minus lambda equal to 0. You know, expanding the 3 by 3 determinant by any row or column. Long back we have done more examples. So I want to expand by first row. So 8 minus lambda into the cofactor of 8 minus lambda by closing first row, first column, into plus symbol into these 4 elements AD minus BC. That is, you know this, all these things. So 7 minus lambda into 3 minus lambda minus 16. Minus of minus 6 plus 6 into deleting second column, first row, minus 6 into this element, minus of 2 into minus 4. So minus 6 into 3 minus lambda minus 2 into minus 4, which simplifies to plus 8. Okay. Plus 8. Next, plus 2 into deleting third column, first row. This is AD, minus 6 into minus 4, 24, minus 2 into 7 minus lambda equal to 0. So, this is 8 minus lambda, lambda square, minus 3 lambda, minus 7 lambda, minus 10 lambda, 7 into 3, 21 minus 16 plus 5. And this is minus lambda into minus 6 plus 6 lambda into 6, 36 lambda. Next, minus 6 into 3, minus 18. Minus 18 plus 8, minus 10. Minus 10 into plus 6, minus 60. Next, minus 2 into minus lambda, 2 lambda into 2, 4 lambda. Minus 2 into 7, minus 14. 24 minus 14, 10. 10 into 2, 20 equal to 0. So, like this, these 2 multiply these 3 terms, you will be getting lambda cube minus 18 lambda square plus 45 lambda 0. After simplifying this one, you will get minus lambda cube. But before solving, it is better express the highest degree coefficient is plus symbol. So that is, if it is a cubic equation, first term symbol is plus, then it is easy to solve that equation. We are all habituated like that in childhood classes. If it is a cubic equation, x cube coefficient, better to put in plus symbol. If you get minus, multiply both sides of the equation by minus symbol. So that after doing that, multiplication minus both sides will give this value. So here in this cubic equation, constant term is absent. According to the simple logic of solving an equations in our childhood class, when a constant term is absent in an equation, definitely that equation has one root, value is 0. If an equation has a constant term present, then none of the roots of that equation is 0. Please remember. Okay. Roots means it finally satisfying the corresponding equation or not. That we are learned from our childhood classes or not. So here lambda common into lambda square minus 18 lambda plus 45 equal to 0. Here inside is second degree quadratic factor. 45 into 1, 45. Minus 18 can be written as minus 3 minus 15. So minus 3 into minus 15 again 45, which is again exact factorization. So this I can write lambda into lambda minus 3 into lambda minus 15 equal to 0. Implies lambda is equal to, each is equal to 0, will simplify to 0, 3, 15. Total 3 values for lambda because of 3 by 3 matrix. All these 3 are distinct eigenvalues of the matrix. So these are distinct. In some problems, some eigenvalues equal or all the eigenvalues equal, that is repeated. So here different is also called distinct. Okay. eigen values of A. While doing your side, that is practicing anything, ignore all these English word sentences so that many of the problems looks like short form or less number of steps only. The next one is finding eigenvector. So for each lambda. So E vector, which is the short form of eigenvector, for lambda is equal to 0, first eigenvalue. E vector means eigenvector, which I am writing in short forms. What is the formula procedure? A minus lambda I into I into, this is a matrix symbol, open brackets or square brackets, is equal to 0. This lambda value we have taken 0. So 0 into I is 0. A minus 0 is A. So this simplifies to A into X is equal to 0. So when A is a 3 by 3 matrix, X is a column matrix or row matrix, which is comparing with yesterday homogeneous equations. It is nothing but homogeneous system. That eigenvalues, eigenvector solving equations, nothing but yesterday homogeneous equations only. So when it is a 3 by 3 matrix, take 3 variables for X. When it is a 2 by 2 matrix, take 2 variables, 2 unknowns for this X. Will give yesterday equations solving. So what is A? 8 minus 6, 2. Minus 6, 7, minus 4, 2, minus 4, 3. Into 3 variables means X, Y, Z, because 3 rows is equal to 0. So you know matrix multiplication. First row into this column, second row into this column, third row into this column, equated to 0 will give 3 row equations. That means 3 equations in X, Y, Z, and you know how to solve. So 8X minus 6Y plus 2Z is equal to 0. So in any equation, if a number is common multiplying, better to shift into, after taking that common number, shift into right side, because right side 0 by any number, 0 into any number is 0. Okay, 0 by 0 is not 0. 0 by any non-zero number is 0. So I can take 2 common, 4x minus 3y plus z is equal to 0. Let us say equation 1. Second row multiplied by xyz will give second equation, minus 6x plus 7y minus 4z is equal to 0. That is, okay, here nothing simplification because no number is getting common. So better to put equation 2. And what is the last equation? Third row multiplied by xyz, 2x minus 4y plus 3z is equal to 0. Equation 3. So from these 3 equations, without using the yesterday method, I will go to solve for xyz by using short method, that is called Cramer's rule method from 11th 12th class. I will explain, which is also called in some textbooks or some people called cross multiplication method. From these 3 equations, which is applicable for 3 by 3 matrix only, what I am going to solve for xyz short method, applicable for 3 by 3 matrix only. Please remember, take any 2 different equations. What is any 2 different equations? 1 and 2 are not same. 2 and 3 are not same. 3 and 1 are not coincide. Okay, all the 3 equations are distinct. So solve any two distinct equations by the method explained now, which gives xyz, that put in a column or row vector, which is called a special name an eigenvector. Now see the method. Solving 1 and 2. Any two, not only 1 and 2, 2 and 3, 3 and 1 will give the same answer for xyz by CM method. What is CM means? Cross multiplication method, short form, cross multiplication method, which is nothing but Cramer's rule or determinant's rule method also. So, the method explained below. Write the coefficients in this order. First middle term coefficient, L means last term coefficient, F first term coefficient, again M middle term coefficient. So, in that equation 1, 2, you consider that order. Middle term means Y, last term means Z, first term means X. Okay? So, that is highlighting by blue color. In the first equation, what is middle term? Minus 3. Last term coefficient, coefficients only, not xyz terms. Next 4. Next minus 3. This is that following that order, middle, last, first, middle. So it is giving completing a cycle. Starts from middle and reach middle also. Okay, that is called completing a cycle. So in which way you have to start and reach middle, last, first, middle. Okay. Similarly in the second equation, correct that order. 7, middle term number, last term number is minus 4, don't write xyz, first term number is minus 6, again 7. So, just by, I am putting crosses by blue color. So, this cross looks like AD minus BC. So, that means product of the numbers corresponding to down arrow minus product of the numbers corresponds to up arrow. This looks like up arrow, this looks like down arrow. So that looks like AD minus BC value, 2 by 2 determinant value. So respectively that gives XYZ values. Okay. Similarly, this product cross minus this product. This looks like cross mark or not. That is called cross multiplication. This cross, this product minus this product. 3 crosses there because we have to find 3 values, XYZ values. Okay. This implies x divided by, how I am explaining, see, minus 3 into minus 4 minus 7 into 1 is equal to y divided by 1 into minus 6 minus 4 into minus 4. Z divided by 4 into 7 minus 3 into minus 6. Okay. Or 1 into AD minus BC. So, in this, x by 12 minus 7 simplifies to 5. Y by, this is also called simultaneous equation. Simultaneous equation means x, y, z values are not unique values. They are having infinitely many values. Minus 6 plus 16, 10. Z divided by 28 minus 18, 10. Again, in these 3 denominators, some number is common, 5 is common. So, you should express every time simpler numbers. 5 ones are, 5 twos are, again 5 twos are. So, therefore, eigenvector is the first lambda value 0. Its corresponding eigenvector denoted by x1. Put it in xyz values column 1, 2, 2 and multiply outside by k. So, what is this k? Where k is non-zero real number. So why I wrote like that? Though we got, it looks like unique values, these 3 equations, first of all, these xyz values 1, 2, 2 satisfying these 3 equations. That means substitute these xyz 1, 2, 2 in the left hand side of the 3 equations. Definitely you will get right side 0. For example, see, 4 into 1 minus 3 into 2, 4 minus 6 minus 2, plus z value 2, minus 2 plus 2, 0. Coming to here. X value 1, minus 6 into 1, minus 6. Y value 2, 7 into 2, 14. 14 minus 6, 8. Z value 2. Minus 4 into 2, minus 8. 8 minus 8, 0. Coming to here. 2 into 1, 2. Minus 4 into 2, minus 4. 2 minus 4, minus 2. Plus 3 into, 2 into 1, 2. Y value 2. Minus 4 into minus 8. 2 minus 8, minus 6. Z value 2. 3 into 2 plus 6. Minus 6 plus 6, 0. Definitely satisfied. If I write only 1 to 2, it looks like unique solution, yesterday's method. Okay, solving equation. It looks like homogeneous equations or not. Yesterday, homogeneous equation system procedure. What are the types of solutions? Either it has only zero solution, that is all variables equal to 0. Otherwise, infinite number of non-zero solutions. 1, 2, 2 looks like a non-zero solution or not. But it seems that here one solution. But yesterday the procedure, infinitely many non-zero solutions. So how do you get infinitely many non-zero solutions? For these three x, y, z values, multiply by any non-zero number will give one by one solution from the infinite solutions. Okay. So yesterday I told you also linearly independent solutions, all these satisfied, same here also. If I take k value 1, x, y, z value 1 to 2. If I take k is equal to 2, x, y, z value 2, 4, 4. If I take k is equal to minus 3, x, y, z value minus 3, minus 6, minus 6. Definitely they are satisfied. Why I wrote like this? For one value of lambda, you have infinitely many number of solutions. Each solution is called an eigenvector. So finally, a note point, or you can consider a property of eigenvalues. For every eigenvalue, for one eigenvalue, we have infinite number of eigenvectors. Please remember. But seems that only one eigenvector. You can multiply by any number. So many xyz values. Each value is called an eigenvector. Okay. So non-zero. Why should I take k non-zero? If I take k 0, then this column vector becomes 0. But I told you eigenvector definition. A non-zero vector x. Please remember. Eigenvector never be 0. At least one of these xyz is not equal to 0. If all 0, while solving, if you get xyz 0, that is your mistake. Okay? Please copy it. So in the remaining, I will give the hint and finally I will provide like this answer. Later you check. And this cross multiplication method is applicable for 3 by 3 matrix only, solving any two different equations. If you solve two coincident equation or same equations, then you will get xyz value 0. But eigenvector never be 0. Eigenvector, that is E vector, for lambda is equal to 3. This is very important procedure for finding eigenvector cross multiplication method. Please take care, everyone. I hope that you are following and understanding also. Now the next one is a minus lambda I, lambda value 3. 3 into I into x equal to 0. So here also what we have done finally, that means we are going to find finally x value, this x value, that is. Why should I put suffix 1? First eigenvector. That means for first eigenvalue the corresponding eigenvector. Okay. Now, how do you obtain A minus 3i matrix? How I told A minus lambda I? Subtract lambda from the diagonal elements of the matrix A. So in the similar way, subtract 3 from the diagonal elements will give A minus 3i matrix. So I hope that you remember that matrix A. 5 minus 6 2 minus 6 4 minus 4 2 minus 4 0 into x y z is equal to 0. Here also you are going to find eigenvector x, question mark. So convert into equations. My 5x minus 6y plus 2z is equal to 0. Equation 1. from the second equation. There is a 2 common. I can write minus 3x plus 2y minus 2z is equal to 0, equation 2. In the third equation, again taking common 2, x minus 2y, z is absent, 0. Okay, so like that. What is this dots, etc.? That means solving as above, which gives eigenvector is x2. For second eigenvalue lambda, I took the notation x2, which is the second eigenvector. So 1 minus 2 into k. Okay. Please take care about this k writing outside, which is not equal to 0. Next, eigenvector for this is I left to you only. You have to solve as above. Lambda is equal to 50. So a minus lambda I now simplifies to a minus 15i into x equal to 0. You are going to find x is equal to question mark. So subtract 15 from the diagonal elements of the matrix A. Minus 7 into x, y, z is equal to 0. In the first row, no number is common. So we convert into equations. Minus 7x minus 6y plus 2z is equal to 0. Equation 1. In the second equation, I can take minus 2 common. So 3x plus 4y plus 2z. In the third equation, again 2 is common. X minus 2y minus 6z. So again, this dots means you have to solve as above, cross multiplication method. Therefore, eigenvector is, the notation is x3. 2 minus 2, 1 into k. So at home, please check my answers correct are. Second one. So the same type of explanation is given in the options in 2015 gate, 2 marks. So I will give the hint and answer also providing. Remember 2 points. For one value of lambda, that is for single eigenvalue lambda, we have infinite number of eigenvectors. Very, very important point. I explained already. Why should I multiply by k? Next, cross multiplication method is applicable for 3 by 3 matrix only and any 2 distinct equations. solving any two distinct equations, that is either 1 comma 2 or 2 comma 3 or 3 comma 1, will give the same answer. Okay. The eigenvectors corresponding to the eigenvalue 1 of the matrix A is equal to one minus 1 2 0 1 0 1 2 1 or so from here with you observe a note point eigenvectors one single value eigenvalue 1, that's why they are asking R, it's not is. So options provided in this notation form, either column vector, row vector, outside multiplying by k or some other letter. Set of all alpha into 4 2 1 such that alpha not equal to 0 and alpha belongs to R. Option B, set of all alpha into minus 4 2 1 such that alpha not equal to 0 and alpha belongs to R. Option C, set of all alpha into root 2 0 1 such that alpha not equal to 0 and alpha belongs to R. Option D, set of all alpha into minus root 2 0 1 such that alpha not equal to 0 and alpha belongs to R. Just earlier I put that xyz values in the column matrix form. Vector means either row matrix form or column matrix form. Here all options whose eigenvectors should represented as row vectors form. This means x value 4, y value 2, z value 1. So I told outside multiplying by k. So he put outside multiplying by alpha. I multiplied by k. His representation multiplied by alpha. Notation is not the matter. Concept is important. And what I told k value about k, if you refer the first eigenvalue lambda 0 corresponding eigenvector, k is non-zero real number. So that verbal language English words convert into mathematical language. Non-zero means not equal to 0. A real number means belongs to R. What is capital R? It is set of real numbers. What is alpha belongs to R? Alpha is an element of real number from set theory from our childhood classes. So for these two notations in English words, verbal sentence is nothing but alpha is a non-zero real number. So answer is option B. Later you check. So I am providing hint. Lambda value 1. You are going to find x eigenvector, question mark. So a minus lambda I, that is a minus I into x equal to 0. Why should I write minus I, a minus I only? Procedure for eigenvector is a minus lambda into I. This lambda value 1 already mentioned. Okay, so put lambda value 1. Now you will get a minus I into x equal to 0. So what is a minus I means? Subtract 1, that means lambda value 1 from the 3 diagonal elements only. So 1 minus 1, 0, remaining elements as it is, minus 1, 2, 0, 1 minus 1, 0, 0, 1, 2, 1 minus 1, 0. 3 variables means 3 rows means 3 variables. X, y, z is equal to 0. So you know converting minus y plus 2z is equal to 0, equation 1. And second equation is option because all are zeros. Third row is there. X plus 2y is equal to 0. Okay, solving implies you will get definitely x value minus 4, y value 2, z value 1. Keep it in row vector or column vector according to the representation. So answer already I told you minus 4 to 1. Okay. So another way of asking this type of eigenvectors. 3, 2010, and E vector, that means eigenvector of the matrix A is equal to, again 3 by 3 matrix, 1, 1, 0, 0, 2, 2, 0, 0, 3 is option A, minus 1, 1, 1 transpose. So each option is again column vector. Row vector transpose means column vector. Sometimes they can express the eigenvector representation is either row vector form or column vector form. Don't worry about that representation. B, 1, 2, 1 transpose. C, 1, minus 1, 2 transpose. D, 2, 1, minus 1 transpose. Solution. Here, lambda value is not given, comma, x is equal to question mark. What is this x? E vector. What is this lambda? E value. So without eigenvalue, how do you find eigenvector? By original method, that is, first find all eigenvalues for the matrix A shown by the first problem. Then for each lambda, find the corresponding eigenvector shown by the first problem. You will get one of the option. In that case, you will have 3 lambda values. We don't know which lambda value we are going to find eigenvector. So it is a critical case. That means it is not critical case, it is time consuming. In that case, alternative method I am going to apply. That is called options method. Whenever eigenvalue is not mentioned, if they require eigenvector. Okay. So denote each option by x, comma, whichever satisfies A into x is equal to lambda into x. That is the required eigenvector. This is, I already told you, another procedure for finding eigenvector. Sir, just now you told A is given, x is, denote each option. This is x, that is x, this is x, this is x. Find A into x. Without lambda value, how can I multiply lambda into x? That I will explain in the options method, A, B, C, D options. Don't worry. So, whenever these two are equal, then the corresponding x in the option is the required eigenvector. So, for example, option A, let that x value how much given? Minus 1, 1, 1. Transpose of a row vector is column vector. Now, implies multiply first A and x, that is A into x. A value matrix 1, 1, 0, 0, 2, 2, 0, 0, 3 into x, that is minus 1, 1, 1. So, multiplication becomes how much? First row into this column, 1 into minus 1 plus 1 into 1 plus 0 into 1 simplifies to 0. Second row into this column, 0 into minus 1 plus 2 into 1 plus 2 into 1 simplifies to 4. Third row into this column, 0 into minus 1 plus 0 into 1 plus 3 into 1 simplifies to 3. So we have done in the option A, Ax. How do you find lambda into x? We don't know lambda value. So, but lambda is some number. X is this option. So for these three, which number to multiply will give the answer 0, 4, 3? Because left side is Ax, right side is lambda x. You don't know lambda value. So don't worry about it. Lambda is some number, any number. So which number to multiply these three which gives 0, 4, 3? Such a number does not exist. So this is not equal to lambda into x. What is that x? Again, this x value. Okay. So this is any number in this case. Lambda is any number into x. What is that x? I hope that you understand. X value is nothing but this. So, therefore, A is not an E vector. That means option A is not the answer. Okay, please copy. So, I will complete later after this option A in the next session. Have a break. Any doubts if you have, please ask the current topic doubts only.